composite materials. We talked about wood, which was the original material for a tool handle. Now they use a lot of metal. You know, things are changing. The world is a changing place. So I improved even that, and I came up with a new generation of handles which has never been done in 200,000 years.
Really?
I came up with a whole new system, and it's affordable. So so there you go. But the rest will all be marketed as these types of handles, and it will be composite material simulating wood, and that hasn't ever been done before. I will have different hammerheads. The hammerheads will be completely different. So that brings me to the next stage. So what we've done is I came up all these different stages of developing tool handles and hammers. There are natural progressions. So that was my focus on the handles. But a tool is made up of the part where the hand holds the tool, and then there is another part of the tool that does the work, like the hammer head. So then there are different types of hammerheads. There are thousands of different types of hammerheads. And I came up with certain types. For example, when you take a look at this hammer, okay, this hammer handle, this hammer head, okay? So the connection that I patented is completely different, because each hammer can have exchanges in the hammer heads. So now each hammer head has specific advantages and disadvantages. So what you see over here, I tried and tested a lot of different hammer heads, and but I started making molds, and this is part of what we wanted to do. There are a lot of improvements that can be made on hammer heads as from a standard type. So when you think about it, so this is a okay, I mentioned before. So when you make a mold, again, metal, usually the hammer heads are made out of metal, and they're drop forged. Some people make, you know, some blacksmiths make them by hand.
Drop forged?
Drop forged, yeah. So what they do is they have a mold, and the piece of steel is hot, and there are two halves of the hammerhead, and it's just boom, boom. That is drop forged, boom, and that is how they make them. But it's a mass production, and I'm not discounting it. That is the way they were made, and they have a specific connection. This is the type of connection that has been made for thousands of years. I changed that. Some people have tried to change it. For example, where the fuck are they? Some people have tried to change it like this, because what the idea was that they wanted, you needed more wood so that it wouldn't break off. So they would have that in here, you know. And so if you take a look at this connection, you see that? So they want more wood. And the theory is that if you have more wood, the head won't break. You see what I mean?
Mm-hmm.
But, you know, it takes a tremendous amount of force to pull a nail. You know, it takes 300 pounds. And so...
Yeah, you have a tool that measures the force.
Yeah. I use the scientific method.
Yeah.
So the connection will be a new patent. Okay?
Okay.
But the gist of what we're doing, what I'm trying to explain, see, in a lot of cases what you have, so, you know, some of the claws broke off, but see, this is cone shaped.
It's cone shaped, okay.
Okay, so now the hammer head, the insert, the female part, has to have a flare out as well. And the idea is, as you tighten that up, it will pull itself tight.
Well, can I see that again? That little piece that you just
Yeah.
put in there? That's the, what is that?
Yeah, that's a spline. That's part of the
spline?
A spline, yeah, that's the patented connection, part of a connection. So as that pulls itself tight, it goes in there. So, and that is why you have to have this. So now, how do you make that? It's flared on the bottom, and it's flared on this side.
Oops, sorry.
So how the fuck do you make that? You see what I mean? So what you gotta do, when you make your mold, you have to take all that into consideration. And so you have to have a you know, the spline in here. See, there's a cone shape in there. See that? So that takes care of the cone shape in the bottom. But now you still have a cone shape up in here. So when you do that, this is, in German you would call it a Kern. You put that piece in there, so now you have to be a mold maker. See, you put that in there.
A Kern?
Kern, K-E-R-N.
Okay.
And again, you could call that a spline. Okay, and then this goes on top. So now when you fill this with your composite material by injection, pressurized injection, it's all designed, and there it's the same thing. So there you go. And then also this is, if you made a hammerhead, you would see this. Again, this is a different type of a head. Okay? So you would... What the fuck are we here? Yeah, there. See? There. So that creates a hollow inside, and again by injection, mold injection, it fills that. You would fill that in with metal, or I'm working on a concept to have a combination, have a composite material, metal and composite.